Hello friends, welcome to our channel Knowledge Amplifier. So in my this particular video, I am going to discuss one very interesting and frequently asked question in interview process related to machine learning or data science domain, right? From statistics part, and that is, what do you understand by sample and population? Okay, very frequently used terms in statistics if you are coming from mathematics background or have done statistics for engineers or some sort of like this kind course, probability theory statistics in your engineering degree. Then I hope you have some idea already, right? So we always study these things in statistics course. So let me give you one brief idea about this. Just try to get the feeling out of this. Okay, so what is population? What is sample? From the name itself we can get some idea. Population data means data from all members of a group. Okay, all members. And sample data means data from some members of a group, not all. Okay, and these some members from a group we select randomly. If you select randomly, then the sample data will basically signify or sample data, that in that case only sample data will be a good representative of your population data, otherwise it won't. Okay, so let me give you with one example. Suppose voting is going on, okay, in a country. Now the original result of voting is population data when we are considering all members vote. Okay, whoever is giving vote for that particular election. But if you consider exit poll, what we do, we take a sample chunk from the overall population who have given vote, and then we ask their opinion, what they think which party is going to win or like that. So basically exit poll is going to be our sample data. Okay, this is the simple idea. So here this particular picture can demonstrate the whole concept of population data and sample data. So this whole one, okay, suppose total capital N number of observation we have, this is population, okay, complete data from all the members of a group. We are taking one small part, okay, which is having total small N number of data. This will come under sample data. Now let me give you some example for population data, in which case we can directly go with population data. Like salaries in a department. You are working in an organization. The organization have multiple departments, right? In the technical field itself, thousands of departments, in the management field, in the marketing field, like that, so on. If you consider all the members belonging to a particular department, then the number of employees is not going to be very huge. Okay, in a department I am considering, right? So that time what you can do, you can get individual data and do data processing, data analysis with that overall information from each member of the department. Okay, so salaries in a data will come under population. Suppose you went to visit a zoo. Obviously there are not very huge amount of lions will be present, so number of lions present in a zoo is also going to we are going to handle under population data. For example, Facebook group members, okay, in a particular group how many members are present, for their data you can collect individually. Okay, that will also come under population data. Sample data example, in which case we need to take sample of the whole population. As you can understand simply, that when our dataset is actual group is going to be very huge, that time what we'll do, we'll take a small part of that and we can do data analysis. Like for example, average height of all the Indians. Okay, now you can understand what is the population of India, and if you go to take average height of all individual and then take average of that, it is obviously not possible in some way, right? So basically that time what we do, we take one small part of the whole Indian citizen and we take their height and we try to represent our overall height of whole population with that height of the average height of the small sample. For example, salaries of teachers in a particular country. How many teachers are present? Many teachers, right? Para teacher, junior teacher, senior teacher. Okay, from professor, different post, associate professors, assistant professor, senior associate professor. Okay, like that. So again, it is going to be a very huge number. So that time what we do, we take a small chunk and we calculate the many statistical things like mean, median, whatever. Okay, that is basically sample representative. Like for example, brightness of stars in Milky Way. In Milky Way, how many stars are present? Literally uncountable. We need to apply image processing. Then also we will be getting one small part only. Okay, so we can never get the whole group information. So then this we will call this as sample data. Now one quiz question for you. Two quiz question. Number one, taking a census of a country. What is this? Population data or sample data? Try to think for a moment. So the answer is this is going to be population. Obviously, whatever the number of people in present in the country does not matter. Census means we are considering, we are counting all individual. So this is going to be population data. Next, voting in a national election. It is going to be population or sample. So the answer is it should be population, no doubt. Above one particular age, whatever according to the rule of the particular country, above one particular age, all should give vote. But not everyone in a particular election give vote, whoever is eligible. Some people give, some people do not give. So that basically, although whole group should give, but basically one sample part, not whole, one sample part, one huge chunk is giving vote for national election. So here also it comes as sample. Although ideally it should be population. Okay, right? So I hope the difference between population and sample, the feeling of the concept is clear to you till now. Now let me go to statistical formulas which are very, very important in machine learning and data science interview respect. Okay, so mean. What is the mean formula? Population mean going to be summation over I equal to 1 to capital N xi, individual data point we are taking by capital N. Generally, what is the mean formula? Total sum divided by total numbers. Okay, capital N, why? Because in our population set total number is capital N we are considering. What is sample mean? Simple, summation over I equal to 1 to small n. Small n is total number of data points present in the small sample part, whatever we are taking, whatever is subset part of our whole population. Okay, so that is nothing but summation over I equal to 1 to small n xi by n. So this population mean is widely denoted as mu, whereas sample mean is widely denoted as x bar. Although just notation is different, but the funda is same. Okay, so now come to another very interesting part, variance. Okay, so what about variance? For population, what we know general formula, summation over I equal to 1 to capital N xi minus mu whole square by capital N. What we generally do. But here is the twist comes for sample. Okay, summation over I equal to 1 to small n xi minus x bar whole square by small n should come, but see here coming n minus 1. Okay, so when we are not writing n, small n, instead of that we are writing n minus 1. Basically what we are trying to do, we are trying to basically increase the variance for sample. Okay, sample data set. Now you may think why we are doing this. Try to understand this very important part. You should have a proper feeling in this particular part. Always the sample should be a good representative of our population. So that means sample mean should be good representative of our population. Sample variance should be good representative of our population variance, right? Now you just try to think. See, one small chunk I am taking of n number of data set, right? And our total population is this one. Now the formula of population mean and sample mean is same, although variance formula is not same. Why like this? See, you consider this image first. Okay, so these all data points are actually our whole data set belonging to population. And these circular parts, whatever I have drawn, These three are belonging to one random sample, whatever we have done from population. Now you can clearly understand that if you consider this sample set, the mean is going to be somewhere middle, and that time the variance is not going to be very high. But if you consider the whole population, the mean is going to appear somewhere here, and the square difference from the individual data point is quite high, and as a result the variance of the population is going to be very high compared to variance of the sample. Okay, so to represent the variance of the sample near to population, we are writing here n minus 1 instead of n. Okay, so that it increased by some amount, and the sample variance can become a good estimator of our population variance. Now you may ask why we are not doing for mean. For mean also same thing should happen, but just try to understand, friends. Here you are taking samples. Okay, now if you take samples many times, but one restriction of same size. Okay, take this sample of same size but many times. Okay, random samples you just take of, suppose n, small n is 20, so 20 samples, each time you choose randomly and consider sample mean of all those. Okay, and then take average. Okay, then take average of all, considering all sample mean. That time it can represent our population mean in a good way, right? Try to feel the idea. Take many samples or consider their sample mean, and then take average of all the sample mean. That time our that output, okay, average of all the sample mean, can be a good representative of our whole population mean. But when you are considering variance or standard deviation, always, as our sample data is very small, so always the variance of the sample data is not going to reach near to population data, because here in the small part you are considering the variance, so variance is not going to be, that is deviation with respect to mean, there is no way to be high. Okay, variance, that is deviation with respect to mean, is not going to be high for very small data set. Okay, but when you are considering the population, then see a huge part, that means that time deviation can be higher. Okay, so if you are thinking that I will take small samples many times and then consider their variance, okay, then take average variance, that might not be a good representative of the population variance. That's why what we are doing, we are basically dividing our sample variance by n minus 1, so that sample variance can be increased by some amount, and that can be a good representative of our population variance. Okay, and what about sample mean? Why we are not doing that? Because what you can do, take sample of same size each time, may take many sample, and then take average of all the sample mean. That can be a good representative of your population mean. But in case of variance, it might not happen, because whenever you are considering variance for small data set, then obviously there is no opportunity to deviate by a huge amount with respect to the sample mean, right? So that time sample variance cannot be very high. Okay, but no doubt population variance, okay, is going to be higher. Okay, because we are considering large area, so for many data set it might happen that it is deviating from the population mean by a huge amount, so that we are making sample variance little bit higher, so that it can be a good representative, or sample variance can be a good estimation of our population variance. So n minus 1, why we are doing, the reason is nothing but we are trying to increase the variance by some amount, so that it can be a good representative of our population variance. Okay, and sample, what about sample mean? Remember this logic, that for sample mean, if we take same size sample and each time we take multiple samples and then take average of all the sample mean, that can be a good representative of population mean. I hope you can feel this idea, why we are not doing for mean, why we are doing for variance. Okay, so I hope you have understood this. This is basically the difference in between mean and variance with respect to sample and population. So this is very important question with respect to machine learning or data science related interview process. I hope you have understood this. If you find this video helpful, please like, share and comment. Subscribe my channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of my latest videos. Thank you for watching.